So you're going to need a worksheet and your reference sheet. So pull out that red reference sheet that I gave you days and days ago. We're going to be using the double and the half angle formulas, and I put them up on the screen. And the double angle formula means the angle you're looking for is double an angle that you already know. So you'll notice in the double angle formula, I've lost my, anybody see my green smartboard marker? Did I put it in my pocket? Oh, there it is. So this says the sine of 2 theta is equal to 2 sine of theta cosine theta. So if I was looking for the sine of 60, that's equal to 2 sine of 30 cosine of 30. Okay, that's what a double angle formula means. A half angle means the angle you have is half an angle that, the angle you're looking for is half an angle that you already know. So if I were to do the sine of 120, and I were to plug that in here, it says sine squared of theta. Now that's a weird way to do it, sine squared of theta, instead of sine of theta squared. This is confusing because you're unsure, do I square the angle or do I square the ratio that comes out of the angle? So if it's written this way, that means square theta, which never happens. And then if it was written this way, that means plug in your theta, find your ratio, and then square it. So to eliminate that ambiguity, we move the 2 in between the sine and the theta. So sine squared of 120 equals 1/2 cosine of double that angle. Sorry, 1 minus the, boy, I'm on fire today. Sorry, 1/2 times 1 minus the cosine of 240. Does that make sense? So double angle means your angle is double some angle that you know from the unit circle. Half angle means your angle is half of some angle known in the unit circle. And for a lot of these answers for your worksheet today, you already know what the answers are because the angles are known angles in the unit circle. So we're just practicing using the double and half angle formulas. And when we get good at that, we'll start doing more angles that aren't on the unit circle. And we'll start combining sum and difference, double and half angles. It can be kind of complicated, okay? Especially the tangents. And if you notice on that last section, they're all cotangents but one of them. So kind of messy. But we're only going to be working the first side of this worksheet today. Okay, so number 1, the sine of 120. Now, I know what the sine of 120 is. It's root 3 over 2. But let's find that using, what does it say, double angle identity. So we're going to use the double angle identity. Is 120 double some known angle in the unit circle? Yes, the 60. So this is the number we're going to use to calculate the sine of 120. So that's pretty easy. 2 sine of 60 cosine of 60. What is the sine of 60? It's the y value. So 2 root 3 over 2. What is the cosine of 60? The x value, 1/2. So those two cancel, and I get root 3 over 2, which is the sine of 120. Piece of cake, right? All right. So you'll notice that the cosine actually has 3 equivalent statements. It doesn't matter which one you use. They all mean exactly the same thing. And when we move on to proving identities, you'll kind of see why cosine actually has 3 versions instead of 1. So it doesn't matter. Do you want to look up a cosine version and square it, or a sine version and square it, or do you just want to look up cosine, or you just want to look up sine? It doesn't really matter. Okay. So let's do number 3. Cosine of 4 pi over 3. Is 4 pi over 3 double some known angle? Which known angle? 2 pi over 3. Now, if you don't understand radians, what's the smart thing to do? Just 4 pi over 3 is 240. Is 240 double a known angle? 120. And the cosine of 4 pi over 3 is negative 1/2. So that should be my answer when I'm done. So the cosine of 4 pi over 3 equal to, which of those three formulas would you prefer to use? Somebody pick one. The bottom one? Okay. So let's do 1 minus 2 times the sine squared of, so we're using this formula here. 1 minus 2 sine squared, what angle is half of 4 pi over 3? 120, or 2 pi over 3. So 2 pi over 3. So 1 minus 2, what is the sine of 2 pi over 3? Root 3 over 2. Well, what is root 3 over 2 squared? Root 3 times root 3 is 3, and 2 times 2 is 4. So it's 1 minus 2 times 3/4. What is 2 times 3/4? Double the top. It would be 6/4, which is 1.5, which simplifies to be 3/2. So 1 minus 6 over 4, which is 1 minus 3 over 2, which is 1 minus 1.5, which equals negative 0.5, which we already knew was the answer. Okay? So when you pick your cosine problem, you might want to look at which angle would be easier to deal with. If I did this same thing using a cosine, so if I use this problem here, 2 cosine squared of 120 minus 1. The cosine of 120 is negative 1/2. We don't have to deal with radicals. So 2 times 1/2 squared minus 1. Oh, that's negative. You're right, but it's not going to matter. So what is negative 1/2 times negative 1/2? 1/4. 2 times 1/4 is 1/2, and if I subtract 1 from that, I get negative 1/2. So really it doesn't matter which cosine version you use, but I like to pick the one that doesn't have any radicals, if that's possible. If it's a 45-degree angle, then you can't avoid it. Yeah, if you square it, then it's going to go away. Well, depending on what you're doing, but yeah. So it doesn't really matter. Okay, look at number 2. Tangent of 60. Just like yesterday, there are 2 ways to find the tangent of 60. One is to use the equation, and the other is to find the sine and divide it by the cosine. And just like yesterday, they both have their pros and cons, and they both do exactly the same thing. So let's do the sine of 60 divided by the cosine of 60. Well, it would be really nice if I could look up the sine of 60, but I can't because I'm supposed to be using the double angle formulas. So the sine of 60 is actually 2 sine of 30 cosine of 30. Everybody get that? Divided by, do we have a preference for a 30-degree angle, whether we want to use sine or cosine? 30-degree angle, sine would not have a radical, but I mean, it's not going to matter because it's going to knock itself out. So divided by 2 cosine squared of, oh, you guys wanted the sine. 1 minus 2 sine squared of 30. Everybody understand that? So, 2 times, what is the sine of 30? 1/2. What's the cosine of 30? Root 3 over 2. Those cancel. I'm left with root 3 over 2 divided by 1 minus 2. What is the sine of 30? 1/2. And I'm going to square that. So 1 minus 2 times 1/4. 2 times 1/4 is 1/2. Am I going too fast? Okay, I'll slow down. Sorry. So 2 times 1/4 is 2/4, which is 1/2. So 1 minus 1/2 is 1/2. So my sine of 60 is root 3 over 2. My cosine of 60 is 1/2. Which I knew sine of 60 is root 3 over 2, and cosine of 60 is 1/2, so I'm doing it right. Now how do you divide two fractions? Just flipping times. So 2 over 1, the 2's cancel, and the tangent is root 3. Oh boy. Now let's use the formula. So, tangent of 60. So the double angle formula requires us to find the tangent of what angle? Of 30, because 60 is double 30. So 2 tangent of 30 over 1 minus tangent squared of 30. Tangent of 30, right here, 1/2, and it's divided by root 3 over 2, but we've done this enough times that we know it's just multiplied by 2 over root 3. 2's cancel, and I get 1 over root 3. I can't leave a root 3 in the denominator, so I convert it. It's root 3 over 3. So that goes on top and on bottom. So 2 tangent of 30 is root 3 over 3. And then 1 minus root 3 squared over 3 squared. So on bottom, root 3 times root 3 is root 9. And the square root of 9 is 3. So this is 1 minus 3 over 3 squared is 9. 3 over 9 becomes 1/3, and 1 minus 1/3 becomes 2/3. Does everybody follow? So the denominator is 2/3. And the numerator is 2 root 3 over 3. How do you divide two fractions? 1 minus 1/3 is 2/3. So no, it's positive. So I need to reciprocate this. 3 over 2, and the 2's and the 3's cancel, and my answer is root 3. Okay? All right. Let's look at number 6. We'll do 6 and we'll do 8. We'll skip 5. 5 is super easy. It is really, really easy. Trust me. When you do number 5, it just solves itself in a hurry. So number 6, a sine of 165. Now this is one of the few cases today where you're actually finding an angle that's not on the list. So it says use half angle. Could you even use double angle to find this? Is 165 double any known angle on the unit circle? No, because you divide it by 2 and you get 132.5. So we have to use the half angle. Half angle formula says sine squared of 165 is equal to using this formula here. 1/2 times 1 minus cosine. What is the double of 165? 330. Do we have a 330? Good. Then it will work. Cosine of 330. Oops, that's not it. This. Now this is a little bit tricky. 1/2 times 1 minus root 3 over 2. Everybody okay with that? So how do we do 1 minus root 3? What's that? So we need to turn 1 over 1 into something over 2. 2 over 2. So 2 over 2 minus root 3 over 2. So 1/2 times 1 minus root 3 over 2. Oh, sorry, there's a 2 there. You're right. Okay. Now what? Do the 2's cancel? No, they don't. No, you'd have to split it again. You could split it into 2 over 2 and root 3 over 2, and then the 2's cancel, but then we're back to where we started. So in order for this 2 to cancel, it has to cancel on both of them, and the root 3 does not have a 2 in front of it. So now I need to bring in this 1/2. So 2, wow, that was weird, minus root 3 over 4 equals the sine squared of 165. Yes? So how do I find the sine of 165? Take the square root. So I'm going to square root, and I'm going to square root. So the sine of 165 equals plus or minus the square root of 2 minus root 3 over 4. Well, can the sine of 165 be both positive and negative at the same time? No, for every angle there is one wall height. It's either a positive wall height or a negative wall height. Which one is it in this case? Well, which quadrant are we in? 165 is an angle that lies in quadrant 2. It's right there. In quadrant 2, is the sign positive or is the sign negative? It's positive, so I'm going to eliminate the negative from the equation because it can't possibly apply. So with the half angle formula, you have to be careful because you're going to get a positive and a negative answer every time, and you have to match it with the particular quadrant you're talking about. Now, sine is positive in which 2 quadrants? The y values are positive in 1 and 2. The cosine would be positive in 1 and 4, and the tangent is going to be positive in 1 and 3. If the sine and the cosine have the same sign, then the tangent is going to be positive, because tangent is sine over cosine. So we use this mnemonic, all suckers take calculus. They're all positive in 1, the sine is positive in 2, tangent in 3, and cosine in 4. Can we simplify this at all? Well, there are kind of 2 ways to do it. If I write square root of 2 minus root 3 over root 4, one way to cancel it is to just put the square root of 4 on the bottom is 2 and be done. But we kind of have this double square root on top. So what happens if I times this by root 4 over root 4? So my one way to solve it is the square root of 2 minus root 3 over 2. And that technically is correct. So we have a double square root that we want to get rid of. So what is root 4 times root 4? So we get a 4 in the denominator. And then what is root 4 times the square root of 2 minus root 3? Where are you going? Is that your I'm trying to be sneaky face? Okay. So we distribute this 4 in, and we have the square root of 8 minus 4 square root of 3. You've never seen anything like this before, right? Well, it's actually the square root of 4 times the square root of 2 minus root 3. Well, I can put that 4 inside, and I have the square root of 4 times 2 minus root 3. Right? Well, this is two multiplication problems. Does the square root of 4 cancel? It turns into a 2, right? Square root of 4 is 2. Then I can put that 2 inside the others. Is this blowing your mind? Okay. So the answer that they want, and I'm just showing you this because it's the way that it's written on the worksheet, is, what number was that? Number 6? Right there. Root 6 minus root 2 over 4. By multiplying that root 4 on the inside. If you leave it the other way, I'm okay with it. Okay. So 9 through 14, you can use any method. Well, depending. Some angles, like 60 degrees, you can double 60 and you can cut 60 in half. But 30 degrees, you don't have a choice. 30 is half of 60. That's the only way to do it, is with a half angle. So number 9 is going to be tough for two reasons. It's cotangent, which is the reciprocal of tangent. So to find the cotangent of pi over 3, we're going to have to find the tangent of pi over 3, and then we're going to have to flip it when we're done. And the fact that it's a tangent problem makes it harder. So, would you rather use the tangent formula, or would you rather use the sine and cosine formulas and then divide them in the end? What's that? What'd you say, Trevor? You'd rather do sine and cosine? Well, let's take a vote. Who wants to do the sine and cosine version? Who wants to do the tangent formula version? All right, tangent formula it is. So, do you want to use a double or a half angle? We're looking here. Do we want to treat pi over 3 as half of 2 pi over 3, or do we want to choose it as double pi over 6? Well, do we want to use this formula, or do we want to use that formula? I think the half angle formula is going to be easier because it eliminates tangent altogether. So if we use the formula, then we don't even have to do a tangent. We do have to square root it, and we have to check to make sure that we're in the right quadrant, but that's not hard to do. So the tangent squared of pi over 3 is equal to 1 minus the cosine of what angle? An angle that's double pi over 3. So double pi over 3 is 2 pi over 3. Because you'll see theta goes there and double theta goes there. So 1 minus the cosine of 2 pi over 3 divided by 1 plus the cosine of 2 pi over 3. What is the cosine of 2 pi over 3? Negative 1/2. So this is actually going to be kind of easy. So 1 minus negative 1/2 over 1 plus negative 1/2. 1 minus 1/2 is 1/2. 1 plus 1/2 is 3/2. How did I ever graduate from college? And then 1 minus 1/2 is 1/2. When I invert the 1/2 times 2 over 1, the answer is 3. But, right, that's the answer to the tangent. So the tangent is 3, therefore the cotangent must be 1/3. Wait a minute. What did I do wrong? Oh, sorry. Tangent squared of pi over 3 equals 3. So now I have to square root. That makes more sense. Tangent of pi over 3 equals plus or minus root 3. What quadrant am I in? Go back to the original angle. We're in quadrant 1, so tangent is positive in quadrant 1. They're all positive in quadrant 1, so I can erase the positive and negative. So the tangent is root 3, so the cotangent is 1 over root 3, which is actually root 3 over 3. That is the cotangent of pi over 3. Okay, are you excited? Have fun. Yeah.